We will continue one important method for solving a biquadratic equation, and this method is named as Ferrari's method. And by using this method, you will find out the solution of a quartic or biquadratic equation. Actually, in this method, what you will see, this method is actually reduces the problem of a biquadratic equation into the factor of two quadratic equation. Now we'll start by considering a general biquadratic equation or quartic equation, and then we will solve some problem related to polynomial equation of degree 4. Now we will just recall some important fact. What should be the general form of a biquadratic equation? Any biquadratic equation can be written as a0 x to the power 4 plus a1 x cube plus a2 x square plus a3x plus a4 equals to 0, where a0 is non-zero and a1, a2, a3, a4 all are basically real numbers. Actually, we are taking the biquadratic equation with real coefficient. This is basically called the general form of a biquadratic equation, in Rx. That means the variable is x and coefficient are coming from the set of real number. Now we'll apply the Ferrari's method for solving this kind of biquadratic equation. First of all, we will divide this biquadratic equation or equation of degree 4. Now, if someone asks you what is the degree of fx, where fx is equals to a0 x to the power 4 plus a1 x cube plus a2 x square plus a3x plus a4 equals to 0, and this degree will be 4. Yes, but the condition is a0 non-zero and all ai are basically real number for all I equals to 0, 1, 2 up to 4. Now here we just divide the biquadratic equation into two types. So you have given a biquadratic or quartic equation a0 x to the power 4, a1 x cube, a2 x square plus a3x plus a4 equals to 0, where a0 is non-zero and all a0, a1, a4 that are basically real number. Now we'll we just make it into two types. The first type is coefficient of the type 1. The first type is coefficient of x cube vanishes. Coefficient of x cube vanishes. So that means in that case, the biquadratic equation looks like a0 x to the power 4, or you can say ax to the power 4 plus bx square plus cx plus d equals to 0. Because the coefficient of x cube vanishes, that means this a1 equals to 0. So it looks like in that form. What is a0? a0 is basically non-zero. Now another type we will consider here. This is type 2. where coefficient of x cube does not vanishes. So where coefficient of x cube, this is non-zero. So in that case, it is exactly looks like a0 x to the power 4, a1 x cube plus a2 x square plus a3x plus a4 equals to 0, where a0, a1, a2, a3 all are real number, a0 is non-zero as well as a1 is non-zero. That means coefficient of x cube is non-zero. Now we will follow the procedure for solving the biquadratic equation type 1 and type 2 both with the help of Ferrari's method. So now we will come to first type 1, then we will move to type 2. So now, working procedure for solving type 1. So what is type 1? Type 1, in that case, coefficient of x cube is vanishes. That means it looks like x to the power 4 plus bx square plus cx plus d, where a is non-zero and all a, b, c, d, these are real numbers. As for example, here you will take one example, x to the power 4 minus 12x plus 5. Or you can take the example x to the power 4 minus 2x square plus 3x plus 15 equals to 0. So these two equations are quadratic and it is basically in the form of x to the power 4 plus bx square plus cx plus d. Here the main observation is the coefficient of x cube is 0. So here the observation is coefficient of x cube, this is basically 0. So now we come to the working procedure. First you will write step 1. Step 1 is write the given biquadratic equation. And you will observe the coefficient of x cube vanishes. So your observation is coefficient of x cube, this is basically 0. Then we will continue type 1. And what will be step 2? Step 2, that equation you can write is fx equals to 0 and 1. Step 2, this equation can be written as, equation 1 can be written as the coefficient of x cube is vanishes. So we can write is x square plus lambda whole square minus mx plus n whole square. This is equals to 0. What is lambda mn? Where lambda mn are basically real number. Now the question is why we have written this in this pattern, because coefficient of x cube is not present. The main objective is we'll use the formula square minus b square and it will be a plus b into a minus b. So it will be a plus b into a minus b equals to 0. That means we will reduce the biquadratic equation into the product of two quadratic equations. This is our main aim. So what will be step 3? We will compare the equation 1 and 2. So comparing equation 1 and 2, we find the value of m square, mn and n square. Okay. Again we will move to step 4, step 5 and step 6. Okay. First we will take one example and we will continue according to the steps. Okay. I will write it all the steps later, but okay, we will continue. So as for example, you have given a problem solved by Ferrari's method. You have given a problem, solve the equation x to the power 4 plus 12x minus 5 equals to 0 by Ferrari's method. So now how to solve this problem is important in graduation level, or it is important in any other examination. Okay, but how to solve? First, I said step 1, write the given equation, Bi-quadratic equation, observe coefficient of x cube equals to 0. Here coefficient of x cube is 0. So now we'll write the equation. The given equation is x to the power 4 plus 12x minus 5 equals to 0. This is our 1. Now we come to step 2. So equation 1, because x cube is not present, so we can continue step 2. So equation 1 can be written as x square plus lambda whole square minus mx plus n whole square. This is equals to 0. What is lambda mn? Where lambda mn are basically real number. This is our 2. Now we come to the step 3. Comparing equation 1 and 2, and we find m square, mn and n square. Now we will comparing 1 and 2, we get, so what is, we get 2 lambda minus m square. This is basically 0. Minus 2 mn. This is basically 12. And lambda square minus n square, that will be minus 5. Now I will explain why this value, we got this value. Now we come to the point. That equation you can write, equation 2 you can write x to the power 4 plus something into x square plus something into x plus some constant term equals to 0. Now we will see x to the power 4, x square plus lambda x to the power 4 will come. Now 2 lambda x square. So from that we will get 2 lambda. And x square term is also present here. That will be minus m square is the coefficient. Now we come to the x. Here no x is present here. Here x is present. That is minus 2mn. Minus 2mn. Notice the constant term in this expression, lambda square. Notice the constant term here, the minus n square. So now you just compare the x square coefficient 1. Here is also 1. X square coefficient is 2 lambda minus m square, that we have written 2 lambda minus m square. X square is not present here, that's why it is 0. And minus 2mn, this is the coefficient of x. The coefficient of x is 12. And lambda square minus m is the constant term. This is basically minus 5. And from this, you can write what is your n square, m and n. So that you can write here m square equals to 2 lambda, mn equals to minus 6 and n square equals to lambda square plus 5. That we have done up to step 3. So step 3 it is done. Now we come to the step 4. So what is the step 4? Step 4 is putting all values of m square, mn and n square in the form m square multiple n square equals to mn whole square, and find one real value of lambda. Okay, lambda is basically a real number. That we will do now. This is step 4. So here m square equals to 2 lambda, mn equals to minus 6 and n square equals to lambda square plus 5. So now eliminating mn, actually we are trying to eliminate. So what we will write now? We will write here eliminating m m and n, we get. So what is our m square? Our m square is 2 lambda. N square is lambda square plus 5. So 2 lambda equals to lambda square plus 5. Actually here we are using m square into n square equals to mn whole square. This relation. And what is mn? This is minus 6. So it will be minus 6 whole square. You will see that is no mn. Only the lambda is present. And from that equation, what you will get? You will get 2 lambda cube plus 10 lambda minus 36 equals to 0. Now we need 1 lambda, that one real lambda, that you can find by the help of cubic equation or by the help of vanishing method. Just you put lambda equals to 1, then lambda equals to 2 and minus 1 minus 2. You will see lambda minus 2 is a factor. If you put lambda equals to 2, that will be 0. So lambda minus 2 is factor. So the remaining part is 2 lambda square plus 4 lambda plus 18 equals to 0. And here you will get lambda equals to 2. And you can solve this part. That will be minus 4 plus minus b square minus 4ac by 2a. Okay, but we need one real value of lambda. That we got already. So we can conclude here one real value of lambda is 2. So our step 4 is done. In step 4, what we have done? We are eliminating here. We are eliminating lambda. We are eliminating m and n. And we are finding one value of lambda, one real value of lambda. This has been done in step 4. Now we will continue step 5. What will be our step 5? Our step 5 will be, now when you will get the value of lambda, then you will find from the value of lambda mn and try to find out the roots and also find the roots of the equation. That is the last step that we will continue now. So now one value of lambda is 2. So now we will find out the value of mn. Since what is m square? M square equals to 2 lambda. So 2 lambda. So that means 2 into 2. So this is basically 4 since lambda equals to 2. And that implies m equals to plus minus 2. Again we have mn equals to minus 6 and n square equals to, here we will see lambda square plus 5. So lambda square plus 5, that means it will be 2 square plus 5, that will be 9, and that implies n equals to plus minus 3. Now we need to decide which value of m is corresponds to which values of n. Since you will see the value of mn equals to minus 6, so we can say m and n are of opposite sign, because you know if the product of two real number is negative, so that means one real number will be positive and other will be negative. So if we take m equals to say 2, then we need to take n equals to minus 3. Why? As they are opposite sign and the product is minus 3. Here you will just check m2, 2 multiple minus 3, that will be minus 6. Or you can take m equals to minus 2. You can also take m equals to minus 2. In that case, your n will be 3. That pair you can choose. So now we are basically putting the value of mn in this equation, in equation 2, because we need the product of two quadratic equation. We need the value in a square minus b square. So what will we just put this value? So from 2, therefore from 2 we get what is exactly given. So from 2 is basically x square plus lambda whole square minus mx plus n whole square. So x square plus lambda. Our lambda is basically 2, that whole square minus mx plus n. So m is 2. So 2x plus n, that means 2x plus 3 whole square. That will be 0. Because our lambda is 2, our possible choice of m is 2 and n is minus 3. So if we put minus 3 here, that will be minus 3. So n is minus 3. So now you just apply a square minus b square. So this formula we know, a plus b into a minus b. So x square plus 2 plus 2x minus 3 multiple x square plus 2. That you consider a and this part is your b. So x square plus 2 plus 2x minus 2x minus, that means plus 3 equals to 0. So that means we get actually product of two quadratic equation, and that we can solve with the help of Siddharacharya formula. So x square plus 2x minus 1 multiple x square minus 2x plus 5 equals to 0. Okay, so that means x square plus 2x minus 1 equals to 0 and x square minus 2x x square minus 2x plus 5 equals to 0. And from that you will solve x equals to minus b plus minus b square minus 4ac by 2a. And from that x equals to minus b, that means plus 2, plus minus b square minus 4ac by 2a. So what will be the value here? The value will be x equals to minus 1 plus minus root 2, comma x equals to 1 plus minus 2i. So thus the roots of the given equation. Now we come to the conclusion. Thus the equation is solved. The roots of the given equation are, given bi-quadratic equation are, one root is minus 1 plus root 2, other root is minus 1 minus root 2, another root is 1 plus 2i and 1 minus 2i. So our type 1, this kind of problem if you have given, you can solve it easily. So now the question is, if you have given this type of question as MCQ type, as for example, the number of real roots of the equation x to the power 4 plus 12x minus 5 equals to 0 is option A 0, option B 2, option C 3 and option D 4. So here I have already shown with the help of Ferrari's method, the number of real roots is 2 and they are minus 1 plus root 2, minus 1 minus root 2, and number of complex root is also 2, 1 plus 2i and 1 minus 2i. So number of real roots is 2. So this answer is correct. All other options are false. So this question is important. That type of question has been asked in different competitive examination and also in the graduation course. In similar way, you can solve the problem. So this is your homework. You can solve the problem x to the power 4 plus 32x minus 60 equals to 0. And also you can solve the problem x cube plus 3x plus 20 equals to 0. Here you will see the roots will be 1 plus 3i. This is your answer. 1 minus 3i minus 1 plus 7 root 7i minus 1 minus root 7i. That means all roots are basically complex, and in that question the number of real roots is basically 0. And here you will see the answer half minus 3 plus minus root 7i and half 3 plus minus root 11i. Again, all the roots are complex, so number of real roots in both the equation, this is your homework. So both the equation are basically 0 because all roots are complex. Now we will do another problem where the x and x square both are present, but okay, this is also type 1. That problem we will solve. So solve the equation. Solve the equation. Solve the equation by Ferrari's method. So what is the equation? The equation is given x to the power 4 minus 6x square 6x square plus 16x minus 15 equals to 0. This is also type 2 because here a coefficient of x cube is vanishes. So type 1 and type 2 basically based on the coefficient of x cube. So this is also type 1. Now we'll come to the problem. So here the solution. First you will write the given equation. This is your step 1. The given equation is x to the power 4 minus 6x square plus 16x minus 15 equals to 0. So this is your equation 1. Now the equation 1 can be written as, because x cube is not present, so the equation 1 can be written as x square plus lambda whole square minus mx plus n whole square equals to 0. This is 2, where what is lambda mn? Lambda mn are basically real number. Now we'll find out basically lambda mn and we'll follow the step. Now step 3, now we just compare. So comparing what from that means it is basically x to the power 4 plus something into x square plus something into x plus something equals to 0. So this will be 2 lambda minus m square, that will be minus 2 mn, and this is basically lambda square minus n square. So we'll compare 1 and 2. So next step, comparing 1 and 2, what we get? We get 2 lambda minus m square. This is basically coefficient of x square, it is minus 6, minus 2 mn, this is 16, and lambda square minus n square, this is 15. And from this you can write m square equals to 2 lambda plus 6, 2 mn equals to minus 8, and n square equals to lambda square plus 50. Now we'll eliminate m and n. So if we eliminate m and n, so now continuation, now eliminating m and n, what we get here? We just use the simple trick, m square n square equals to mn whole square. So that means we will put the value of m square first. This is 2 lambda plus 6. What is n square? This is n square plus 15, and that is basically minus mn whole square. So minus 8 whole square. So this is lambda square plus 15. So this equation will be lambda cube plus 3 lambda square by simplification plus 15 lambda plus 13 equals to 0. Now you can apply the Cadence method. It will take more time, but you just apply the vanishing method. Lambda equals to 0, lambda equals to minus 1, lambda equals to 1 and 2. You will just check in which values of lambda this equation will vanish. You will check when lambda equals to minus 1, that will be vanished. So lambda plus 1 is a factor. So that you can write lambda plus 1 into lambda square plus 2 lambda plus 13. So that means you will get one real value of lambda. This is minus 1. And the other value is minus 2 plus minus 4 AC by 2 into A. So therefore we get one real value of lambda. This is basically minus 1. We need only one real value. That is sufficient for finding the value of mn. Okay. Now we'll find out the value of mn, the basis of the value of lambda. So here lambda is basically -1 that we get on the real value of lambda. So now what should be your m square? Your m square is basically 2 lambda plus 6, and you will put the value of lambda, that will be 4. So your m will be plus minus 2. And what will be the n square? Your n square will be basically lambda square plus 15. That means it will be 16. So what is the value of n? The value of n is plus minus 4. Now what is the value of mn? The value of mn is basically -8. -8. That means lambda for these values mn equals to -8. M and n must be of opposite sign. So m and n are of opposite sign. Opposite sign. That means if we take m is positive, then n will be negative, and if we take m is negative, then n will be positive. So now we are basically this is our choice. We take m equals to 2, and on that case n will be -4. You can choose m equals to -2, and in that case your n will be 4. So this is your choice. So now we have taken this value m equals to 2, n equals to -4, and in that case from 2 what we'll get? We get, what is the equation 2? Equation 2 is x square plus lambda whole square plus mx plus n whole square. So from 2 we get x square plus lambda. So lambda is basically -1, that whole square minus mx, that means 2x plus n. So this is basically -4, that's whole square equals to 0. From that you just apply square minus b square formula. So what you will get? X square -1 plus 2x minus 4, and x square -1 minus 2x plus 4. Just a plus b into a minus b. We'll get to quadratic factor. So here the factor is x square plus 2x minus 5 multiple x square minus 2x plus 3 equals to 0. So now what will be the root? X equals to minus b plus minus b square minus 4ac by 2a, and from this your x will be minus b plus minus b square minus 4ac by 2a. So what will be your x? Your x will be -1 plus minus root 6 and -1 plus minus root 2i. So we get the solution. Therefore, the roots of the equation are, what are the root? -1 plus root 6, -1 minus root 6, -1 plus root 2i, and -1 minus root 2i. Now the question is, you have asked this kind of MCQ question, MCQ type question. The number of real roots of the equation x to the power 4 minus 6x square plus 16x minus 15 equals to 0 is option A 0, option B 1, option C 2, and option D 4. So here the number of real roots, you will see -1 plus root 6 and -1 minus, this is 2, and other two roots are imaginary. So number of real roots is 2, and all other options are false. Okay, now we'll continue the third type. Type 3. Type 2. So what is type 2? Where x cube are basically present. So now we will continue type 2. So type 2 basically coefficient of x cube. This is basically non-zero. That means the equation looks like ax cube, ax to the power 4 plus bx cube plus cx square plus dx plus e equals to 0. But the condition is A is non-zero and B is non-zero. So that means the coefficient of x cube is non-zero. And A, B, C, D all are basically real number. So this is basically type 2. And how to solve this kind of problem? So again you will write step 1, the given equation. The given equation is, so this will be basically fx equals to 0. This is bi-quadratic equation, that equation of degree 4, that is 1. Step 2, this is different from the step the type 1. So here the equation, because x cube is present, the coefficient of x cube is non-zero. That means x cube is present. So the equation can be written as, this is very very important steps, x square plus some kx plus lambda, that whole square minus, it is also a square minus b square form, but this part is extra, kx plus lambda. Now the question is, what is k? Where k, that is determined as soon as possible. This is basically a half multiple coefficient of x square. This is the trick. So that means it is basically c by 2. The coefficient of x square, here you will see the coefficient of x square is c. So c by 2. And what is lambda mn? This is basically real number that we need to determine. Now you just follow as the previous type and you will continue and you will get the solution. So next step remains the same as type 1. So now we will continue one important problem and you will see how to solve this kind of problem easily. So here the problem is, so I have chosen one important problem here. The problem is solve the equation x to the power 4 plus 2x cube minus 7x square plus 8x plus 2 equals to 0 with the help of Ferrari's method. So here in type 1 and type 2, only this position are basically different. So now we'll read the first step. The given equation is x to the power 4 plus 2x cube minus 7x square plus 8x plus 2 equals to 0. Now observation is that the coefficient of x cube are basically non-zero. This is the observation. So the equation 1, this is equation 1. So therefore equation 1 can be written as what I said, x square plus some k into x. Now the question is, what is k? K is basically half into coefficient of x square. So what is the coefficient of x square here? So this is basically what I said. I said coefficient of x square. No, it will be coefficient of x cube. So that means C. So B will play the important role. So what is the coefficient of x cube? So coefficient of x cube half multiple. The coefficient of x cube is 2. That is required, not x square. I said the wrong thing. So half into 2, this is basically 1. So our k is 1. So k into x, that means 1 into x plus lambda a whole square minus mx plus n whole square equals to 0. Where what is lambda? The lambda mn are basically real number. This is equation number 2. Now we compare these two equation as previous. So you can write the equation. You can write this equation in the form x to the power 4 plus something into x cube plus something into x square plus something multiple x plus some constant term equals to 0. Okay. Now this will be x to the power 4, and that will be 1 plus 2 lambda, the coefficient of x cube, that will be that will remain the same. So that will be 2x cube, and the x square coefficient will be 1 plus 2 lambda minus m square, and this coefficient will be, the coefficient of x will be 2 lambda minus 2mn, and the constant term will be lambda square minus. Just you will compare and put. So comparing 1 and 2. So what we get? We get x square coefficient 1 and x cube coefficient is 2 and 2. That will be the same. This part remain the same. Starts from that. So 1 plus 2 lambda minus m square, that will be minus 7. Coefficient of x cube is minus 7. Then 1 plus 2 lambda. So then 2 lambda minus 2mn. So 2 lambda minus 2mn. This is basically 8. So that you will write. Next, lambda square minus n square, that will be 2. So the constant part is basically 2. Okay. So I said the wrong question. Here it will be 12. It will be 12. And that will be 12. Okay. So now we will calculate here the value of here you will see the m square equals to 2 lambda plus 8, and what will be mn? Mn will be lambda plus 4, and what will be the n square? N square will be lambda square minus 12. So now we will eliminate m and n. So eliminating m comma n, what we get? We will apply here the simple trick, m square n square equals to mn whole square. So m square is basically 2 lambda plus 8. N square is here, what is n square? This is lambda square minus 12. So lambda square minus 12. And what is mn? Mn basically lambda plus 4. So that will be lambda plus 4 whole square. So now you will do the simple calculation. You will see here 2 lambda cube plus 7 lambda square minus 32 lambda minus 112 equals to 0. And by simple calculation, you will see lambda minus 4. You will put 1, 2, 3, 4 by using vanishing method. Lambda minus 4 is a factor. So that will be 2 lambda square. That we will continue. So what is the value of lambda? Lambda value is 4. And another value we will write here. So 1, real value of lambda is 4. So we need at least one real value. Because this is a cubic equation, it must have a real root. At least one real root. So now we will take when lambda equals to 4. So then the value of m square. The m square is basically 2 lambda plus 8. So 2 into 4 plus 8. So this will be 16. And from that your m will be plus minus 4. Now what will be the n square? N square value is basically lambda square minus 12. So what is the value of lambda? So 4 square minus 12. So this is basically 4. And n value is plus minus 2. And what is our mn? So our mn is basically 8. Now since m and n are 8, since m and multiplication is 8, so that means m and n are always of the same sign. So m and n are of same sign. They are not opposite sign. In the previous two problem you have seen mn sign will be opposite because mn is negative. Now mn is positive. Either they are both greater than 0 or they are both less than 0. Now I am continuing here. So mn are opposite sign. So we take same sign. So we take m equals to 4 and n equals to 2. You also choose m equals to minus 4, n equals to minus 2. No problem. That will give you the same answer. So if we choose m equals to 4 and n equals to 2, in that case, hence equation 2 becomes so what is our equation 2? Equation 2 is x square plus x plus lambda whole square minus mx plus n whole square. So x square plus x plus lambda, our lambda is 4. That whole square minus mx plus n. So our m is 4 and n is 2. That whole square equals to 0. Now we can apply square minus b formula. We will get a plus b into a minus b. That means we are reducing the biquadratic equation into the factor of two quadratic equation. So x square plus x plus 4 plus 4x plus 2 x square plus x plus 4 minus 4x minus 2, that will be 0. So here the factor will be x square plus 5x plus 6 and x square minus 3x plus 2 equals to 0. Now we will solve it easily. So that will be x plus 2 into x plus 3 and this will be x plus x minus 1 into x minus 2 equals to 0. So from this you will get this 2. From this so what are the solution? X equals to minus 1, minus 2, 1, minus 2, minus 3, 1 and 2. So here the roots of the equation are, roots of the given equation are 1, 2, minus 2 and minus 3. Okay. So here you have asked the MCQ type question. The question is like this: the number of real roots of the equation. You have given the biquadratic equation x to the power 4 plus 2x cube minus 7x square minus 8x plus 12 equals to 0 is option A 0, option B 1, option C 2 and option D 4. So option D is correct, all other options are false. So now I will give you some assignment. So solve by Ferrari's method. So first question is x to the power 4 minus 10x cube. This is one important question. 35x square minus 50x plus 24 equals to 0. And another question, solve x to the power 4 plus 4x cube minus 6x square plus 20x plus 8 equals to 0. So these are two also important questions that is given as an assignment homework and you will solve it easily. Okay. So in that case, for the last case, you will see the answer minus 3 plus minus root 7, 1 plus minus root 3i. So that means that the number of real roots is 2, number of imaginary root is 2, number of complex root. And here you will see number of purely imaginary. So here you will see in that problem, you will see the roots are basically 1, 2, 3, 4. Okay. So here you will see the roots are 1, 2, 3, 4. And this problem is also interesting. So this is very, very important. This question has been asked in many graduation course in B.Sc level. Okay. So thank you so much.